Hey everyone, in our previous session, we have discussed about the scalability in high-level system design. We have seen how our scalable system can handle sudden spikes in number of users requests. In this session, we will discuss about the availability. We will see what is availability in a software system and how high-level design can help us to design a highly available system. Availability of a software system ensures very less or no downtime. Software system should be always accessible and functional for users. That is known as availability of a software system. However, there are challenges to design a highly available system. Keeping a software system always available is not an easy task because a number of components of a software system are bound to fail. Servers are prone to power failure, insufficient resource failure, etc. Not only servers, even programs or code cannot be bug-free in a practical situation. And the network is the most vulnerable component in a software system. It can fail very frequently. Keeping all these in mind, we have to design the system so that it will be highly available. We will see a number of approaches through which we can make our system highly available. Before that, let's understand how can we quantify the availability of a software system. In software industry, usually availability of a system is measured in percentage using 9 counts. For example, 2 nines means 99% available. But is it a good availability number? The answer is no, because even 99% available system will be unavailable for 36 or 37 days in a year, which is not acceptable at all. That means your user will not be able to access your system for 36 days in a year. In such cases, it will be really annoying for a user to use your system. Hence, 2 nines is not a great availability number. Even 3 nines are nothing but 99.9% availability. Even for this, your system will be unavailable for nearly 4 days in a year. Hence, for a large scale system, we have to achieve 5 nines or 6 nines. 5 nines means 99.999%. That means nearly 6 minutes your software will be unavailable throughout the year. If we spread this 6 minutes throughout the year, it is negligible. Hence, your users will not be sometimes aware that your system is not available. 6 nines means 31.5 seconds of unavailability in a year. These are the great numbers for highly available system. For a highly available system, we should achieve either 5 nines or 6 nines. However, there are some mission critical systems where even 6 nines will not work. For such cases, the highest magnitude of availability of a system will be usually 9 nines. That means 0.6 seconds of unavailability in a year. Hope you have realized how we can quantify the availability of any software system. Remember, system is available if and only if it is serving the users adhering predefined SLA or service level agreement. That means even if your system is up and running, it does not mean that your system is available. As an example, if your system is taking minutes to respond to any user's request, where as per SLA, the request should be served within milliseconds, in such situations, your system will not be considered as available system. Hope you have realized the definition of availability in a software system. Let's now concentrate on the design approaches for any highly available software system. Replication or redundancy is the key. Redundancy of system components enhances the system availability. Because even if one instance of any component of your software system has failed, the other instances of the same component can handle the user's request. Hence, from user's perspective, your system is highly available. Let's understand it with an example. This is a high-level design of a simple system where let's assume we have users who is communicating with the load balancer, and load balancer is in turn communicating with the service layer of our system. Now, as we have two instances of the same service, even if one service fails, the other instance of the service can always handle the user's request. However, if you see, load balancer is a single point of failure in our design. That means if load balancer fails, the entire system will be down. Not only load balancer, even our database can fail. And if our database is unavailable, the entire system will be down. In order to handle such situations, we should ensure that there is no single point of failure in our system design. Hence, to make this system highly available, we have to increase the redundancy of the load balancer. Instead of a single load balancer, we can have two instances of the load balancer. Similarly, for DB also, we can have replication. In this way, using replication technique, we can increase the availability of our software system. There are a number of replication approaches. Primary backup replication, where we will have a single primary node and multiple backup nodes which will be idle in normal condition, and as and when our primary node fails, one of our backup nodes will act as primary again. Apart from primary backup, we can have master-slave replication as well, where master node will be used for both read and write operations, whereas slave node can serve the read operations. In that way, we can increase the scalability of our system as well. We can have active-passive replication or active-active replication. Apart from these replications, we can also enhance the availability of our system with the help of data partitioning or sharding. In our subsequent sessions, we will see all these different types of replications what we can use while designing a system. Hence, now you know how replication or redundancy of our system components is enhancing or helping us to design a highly available system. Understanding on availability of a software system is incomplete without knowing CAP theorem of distributed system. As per CAP theory, among consistency, availability and partition tolerance, we can only achieve any two. That means either we can achieve consistency and availability. In such cases, our system will not be partition tolerant. We can have availability as well as partition tolerant system. However, for such systems, consistency will be on top. Otherwise, we can have consistent as well as partition tolerant system, but those systems will not be highly available anymore. Consistency or C ensures that all nodes will have access to the latest information. Availability or A ensures system always returns a result even if it is a stale information. On the other hand, P or partition tolerance ensures the system will be available even if there is a communication failure between nodes of a distributed system. In our subsequent sessions, where we will be discussing on the database design, we will come back to this CAP theorem again. Let's summarize the session now. In this session, we realized what is availability of a software system, what are the different challenges we have to remember while designing a highly available system. Now we know how can we quantify the availability of a software system using 5 nines or 6 nines. We realized if a system is up and running, it does not mean that our system is available. in order to keep our system available, our system should serve the users adhering the predefined SLA. We have seen how we can design a highly available system by replicating its critical components. We have also seen the cap theorem, where among consistency, availability and partition tolerance, we can have any two. Remember, replication and redundancy increases the complexity of your system and cost. Hence, replicating each and every components of your software system is not a good idea. For example, here we don't need to replicate the cache anymore, because even if you do not replicate the cache and cache fails, our system will be still available, because instead of taking the data from cache, we can communicate with DB and fetch the same information. Hence, replication of cache is not a mandate to make your system highly available. Keep this in your mind, that high availability compromises the consistency from the cap theorem, cost because we have to replicate each and every component of our system, and also increases the complexity because of the replication. So, based on the use case of your system, you have to make a trade-off and take a decision to make your system highly available. Hence, while designing a highly available system, we have to think about our use case, understand the trade-off between availability, consistency and the cost or complexity of our system. Hope you have enjoyed this session. Thanks a lot for watching this video.